Dear students, greetings and hope all is well with you. Welcome to the Drilling and Blasting, the course that is being taught in year 4, Mining and Geology, and we'll be together with Professor Dinya Wabuhungu, who is this model leader. So, a quick introduction. We all know the mining cycle and the sequence of activity that are being taken in mining. One is prospecting, the second exploration, mine development, extraction, and mine closure, where we have rehabilitation and the mine reclamation. And the prospecting and the exploration are the main duties of a geologist. The mine development and the extraction are the main duties of mining engineer. So we all know that the most economic mineral deposits are found into massive rocks, and these rock mass need to be fragmented to obtain the variable and separate the material for further processing. Breaking a rock must involve the energy, and that can be only achieved by drilling and blasting. Thus, drilling and blasting are considered to be the first phase of production cycle in the most of mining operations. So there are two basic operations that are necessary to achieve success in mining. One is drilling, the second one is blasting. Drilling is the operation of creating the blast hole that will be used specifically for charging and stemming for the local breakage. Blasting is a process of breaking the back rock mass into small fragments using explosive compounds. And the explosive are the chemical substance or the device used in blasting. Explosive material, also called explosive, is a reactive substance, a chemical reactive substance that contains a good amount of potential energy that can produce explosion if released suddenly, usually accompanied by the production of light, heat, sound, and pressure. There are three common types of explosive used in blasting. One is chemical, the second is mechanical, and the third is nuclear explosive, as well as the type of energy that may be stored in respective type of explosive. So a detonator is a device that is used to trigger to initiate the explosive device, and the detonators are classified also into three main types: chemically, mechanically, and others. So with the classification of explosive are being classified mainly into two class. The one is lower explosive and the second one is higher explosive. And the high explosive have two groups. The one is primary explosive and the second one is secondary explosive. And these are being classified depending on the speed, the detonation speed, and the chemical composition of that. Here we have a primary explosive and the lower explosive and the high explosive, and the primary explosive is actually under higher explosive. The primary explosive are highly sensitive explosive which explode on the receiving a slight shock or by fire. And here are examples: lead, azide, and the mercury fulminate, and the others. So low explosive are simply burn and don't explode suddenly. The chemical reaction taking place in such explosive are comparatively slow, and their burning proceeds from the surface inward in the layer and to the approximate rate of 20 centimeter per second. Examples, this one example, gunpowder or black powder, and this is actually a mixture. Black powder is actually a mixture of 75% of potassium nitrate, 15% of charcoal, and 10% of sulfur. These are mainly used in blasting in shells and igniters for propellant bombs. So smokeless powder, which is a nitrocellulose, it is prepared by treating cellulose with nitric and sulfuric acid It is called the smokeless powder because it actually produces carbon dioxide, carbon monoxide, nitrogen, water vapor, and almost no or smoke one can see. So higher explosive, as I told you, higher explosive having a higher energy content than primary explosive. Even the primary explosive in the higher explosive as we see it later on. So they are stable and quite insensitive to fire and mechanical. This type of explosive, they can't suddenly explode with just a very short or a very short mechanical disturbance. So plastic explosive, the combination actually of explosive in the plastic state, and they can be handled, molded, changed into shape without any serious risk. So dynamite, they are containing nitroglycerin as a principal ingredient in oil, which detonates by pressure shock or spontaneously above 50%. Straight dynamite and blasting your times dynamite are kind of examples. So summarized the explosive type, we have lower explosive, and this type we actually have a slow and deflagration explosive. This the detonation, the velocity of the VOD, velocity of detonation is actually under 2,000 meters per second, and it includes gunpowder, explosive compound for fireworks, practically non-applicable in mining and civil engineering activities, with exception of unmarked work. So in the high explosive, actually, these are the explosive with VOD, a velocity of detonation, which is between 2,000 and 7,000 meter per second. Among others, we have primary explosive and secondary explosive. And the primary explosive is sensitive to stimuli like weak mechanical shock, spark, flame, mercury, fulminate, lead, azite, lead, sulfonate are generally used in the detonators. And also the secondary explosive, which is capable to detonate only under the influence of shock wave. Oh yeah. So the gunpowder, which is known as black powder, is chemically explosive, and it is earliest known. It is from the early starting. Yeah, it is a mixture of sulfur, charcoal, and the potassium nitrate that is called the saltpeter. These sulfur and charcoal act as a fuel, and the saltpeter is an oxidizer because its burning properties and the amount of heat and the gas volume that it generates. Powder are being widely used, and it is classified into the lower explosive. So gunpowder, as is simple, commonly cited the chemical equation, as you can see, it is a compound of potassium nitrate, sulfur, and carbon, which is charcoal. Because of its lower brisance, black powder causes fewer fractures and results in more usable stone commonly to other explosive, making black powder useful in most of activities. So list of underground, list of ground vibration. As I told you, the blasting resulting to the noise, ground vibration, the breakage, damage of infrastructures around the blasting area. So there are also property loss due to the ground vibration, the damage of hearing, loss of hearing capacity for the people around the blasting area because of the noise, higher noise of that is produced from the blasting operation. Yeah, property loss, damage to buildings, structure, damage to underground services or utility, due to maybe underground vibration or ground vibration. A failure occurred to geotechnical features or geotechnical infrastructures and noise sense. Like the people around the blasting area does not don't feel like they are good because of the kind of noise, the kind of ground vibration, and also the complaints. The people around the blasting area that are always nearby, they are always complaining. You see our houses are being damaged by the ground vibration from the blasting operation that I do there, and there is a regulation stating that the people, at least the infrastructure that should be nearby the blasting area should at least be in 5 to 700 meters far from the blasting area. So that's actually a law, but also there is a law stating that there is uh, to have equipment that should be there to measure the 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 magnitude of ground vibration, that is called the seismograph, and also the noise intensity of the noise. Yeah. So the blasting is important. One, because it helps us to break down the lock mass for easy the task of getting out the fragments with a mineral of economic interest and for further processing. But also an issue because the people around that are complaining noise, the infrastructure damage. So that's one very important, and the second is a problem to the environment near the blasting area are being damaged because of the some fly locks, the locks that are flying from the blasting operation. So why blasting a part of being one to help us to reduce the size of the lock mass for easy to get out the mineral of economic importance or deserve. Why is this blasting necessary, and how is the blasting air blasting controlled? How do we know if if there's a vibration and air blasting level are safe, and what is the main technical objectives of primary blasting? So who may conduct blasting and what important timing of detonation? These are some of the questions that you might be asking yourself. So here is the blasting. Why? So it is the most cost-effective way to fracture slope so that it can be excavated by earth moving equipment. This in turn reduces the cost of breeding material such as gravel, concrete, energy produced from coal, and many other products derivative from limestone and coal, and even other minerals. So how is the air blasting controlled? There are thermal controlled blasting techniques or types. Among others, we have muffled controlled blasting, we have casual, we have, and there are so many. So air blast is sudden movement of air that occur in underground mining system where carving develops an extensive mass of unsupported rock spanning a large void. So air blast is controlled mainly by the proper use of stemming, and the stemming is actually the confinement of energy into the blast hole. After creating the blast hole, you need to clean that, and you introduce your explosive, you introduce your ammonium nitrate or amphor, you introduce your detonating cold. After that, you need to confine those blasting material into the blast hole. and you need to make sure that the energy of those material, those blasting material, are much strongly confined under the within that blast hole. So the air blast is controlled mainly by the proper use of seaming material. Those are the drill cut or crush the stone dam that are shoveled back in the holes after the explosive material has been loaded to a predetermined depth from the surface, and by not loading explosive into the position of holes with cracks, void, and muds. These techniques minimize the escape gas and confine the explosive gas energy where it is needed to efficiently break down the lock. So, who may conduct blasting? Uh, you may ask, who is allowed to conduct blasting? For example, here in our country, not everyone has the right to conduct the blasting operation. Only a certified blaster may conduct blasting in quarry, underground, or surface mine. To become a certified, the blaster must obtain specific training on blasting, crew experience, including the job training. So the time depends on which institution that is delivering those trainings. So what are the main techniques or objective of primary blasting? So the primary blasting is there to excavate the planned volume of rock from within the defined boundary. So to achieve acceptable also fragmentation, it means the desired maximum the average size of broken rocks particle without excessive or dust or fine materials. So also to avoid scattering of broken blocks that are achieving the desired heap of rock, which is easy to load or remove from within the area of blasting area. So what is the important timing of detonation? To this one is there to limit the amount of energy released at any point in time, or to avoid the damage of sounding rock or installation. This also is there to ensure that the holes detonate in the planned sequence, so that each successive hole has a free face within the with the appropriate burden. So here also will be the topics that you will be presenting about, and I do hope that you will make it, and there is not that much complicated. So the first group is one will be presenting on the importance of rock mass property in drilling and blasting. You have studied the rock mechanics, you know rock mass properties in the classification of rock mass classification, you know that. So why is that important to know the property of this rock mass for the drilling and the blasting? The second group will present on the ground vibration and the noise controlling at blasting. There are different techniques of blasting controlling blasting, so you shall be able to identify which one is the best for specifically underground vibration. There are also control the blasting and the air blast limits. I think there are some limits for air blast and controlled blasting, so you will be in identifying that method and the pattern of charging blast hole. The group 4 group 5 will be presenting on rotary blast hole drilling bit, and this group 6 will be presenting on explosive, the history, composition, and the test. What is the origin of or history of this kind of explosive? What is the composition? I mean, chemical composition, and even the taste. How can I test that this type of explosive is even good than that one, and is still active to be used. So also important of pre-splitting and the post splitting. That's pre-splitting is actually control the blasting, so and the post splitting. So you should identify the importance of them, also the mechanic of rock fracture, and that will be. So thank you so much. Thank you so much for your kind attendance, and I wish you all the best as you are taking this very important course in mining activity. And anytime whenever you have a question, a problem, a discussion, don't hesitate to contact us. I have shared my email and even the email of the model leader, which is there also of course Professor Digne Rwabuhungu. You can reach us, no problem. We will be there to help. So thank you so much. I wish you all the best.